when I was very young, I was very curious. I really liked quantum mechanics. Okay, and by that time, it was the early 2000s. It was the time when quantum information and quantum computing started to pop up. Okay. By that time, everything was like very preliminary, but I got very interested in what was going on. And afterwards, we realized that the same methods that we were applying to understand quantum computers, we could apply them to understand also quantum states of matter. And I just found that extremely interesting, no? Because to me, it was a more direct and immediate application, okay? Apart from the long shot of having a quantum computer, we could have suddenly a better understanding of what are the quantum phases of matter and so on. And that was an open problem. I was very, very, very interested about that, and that really kept me going on, and it still keeps me today. Yeah, I think every time that somebody asks me about the evolution, I always say the same thing, that we couldn't forecast 20 years ago. We couldn't forecast that today we will be here. So I always have the feeling that the future happens much faster than everything that you expect, okay? I think there have been many developments in the last years that have really made the field explode, okay, in a good sense, no? And it's somehow happening what was happening also with classical computers, no? So we had classical computers in the 30s that essentially occupied a full building, okay? So nowadays we have quantum computers that they are huge, no? They are a whole lab. And we are more or less in that phase, okay, nowadays. But as I was saying, maybe 20 years ago, I could not imagine that today we will have the technology at the point that we have it now. I foresee a future where people will be using quantum computing, but perhaps without noticing, okay, because the model of computation is also changing. It's not, so nowadays everybody has a computer, even in their phones and so on. But most of the calculations that you are running when you have apps and all that, they are running on the cloud. So you don't have actually the physical device with you. It's running on the servers of somebody else. So I think that there's going to be a cloud model also for quantum computers, okay? And we are going to be users, all right? We are going to be using our technology, and we will not notice, but at some point when there is a very hard computational problem, instead of solving that on a classical computer, it will run on a quantum computer that will be hosted somewhere else, okay? Having said that, that doesn't mean that we will not have quantum technology with us, okay? So perhaps we'll have some quantum, some quantum sensor or something going on probably in our phones or on our laptops. Yeah, this I think it's going to happen, yeah. I think there are several challenges that quantum computers are facing nowadays. I think the most important one is scalability, because nowadays we have the first prototypes of hundreds of qubits, which are noisy and so on, but still, they are very interesting. But we don't have quantum computers with millions of qubits, and that's the thing that we would like to have. No, we don't want to have 100 qubits that have a little bit of noise and so on. We want to have millions of qubits that are error-free, error-corrected, and all that. And how to go from 100 qubits to millions, that's a problem, okay? I think that's the main challenge nowadays, and that's a challenge for the hardware. Now, on the software side, and also on the application of these technologies on daily life, I think there is a challenge in making society and industry in particular also more aware of these technologies and teach them how they could be using them for solving particular problems that they have in their daily lives. Yeah. Well, it depends. It depends on what do you mean by understanding quantum physics. Obviously, there are many different interpretations. We don't really understand what the equations of quantum mechanics are trying to tell us. With this, I agree. But that doesn't mean that we cannot use it, all right? And that's exactly what we are doing nowadays. We have these equations, we have these theories. We don't really understand what they mean in the deep sense. But we can use it, okay? And that's exactly what we are doing. So my advice for young people now is that if they really like quantum mechanics, this is a fantastic moment to actually be in the field, okay? When I started in all this, everything was very preliminary. It was more a romantic thing that I was pursuing. I never thought that I would ever see a quantum computer in my lifetime, no? And nowadays we have quantum computers and so on. There are even companies, there are lots of funding, there are many conferences like this one going on. I think this is a great moment for young people to actually, come to the field. Yeah.